Hey everybody, this is Larry. This is day 15 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. I think today's tax day, right? Obviously in the US, so hopefully everyone did well with respect to that. But yeah. Okay, let's see. Okay. I have a full disclosure here. Hit the like button, hit the subscribe button, join me on Discord. But also, I I went out a little bit late tonight, or like right before this. There's a lot of alcohol situations, so if I'm a little bit slow or if my words a little bit unclear, let me know in the comments and I could try to clarify. But with all that being said, let's get started on today's farm. 669, trim a binary search tree. Okay, so which one is this? Giving trim the elements of that or the elements at low and high. Okay, that should be. I think this is one of those cases where. I mean, okay. So if you've done yesterday's farm and if you haven't, I recommend it about binary search tree and finding an element in it. But so this problem is going to be just an example in carefulness and maybe a little bit of practice and a little bit of just going for everything. Okay, what are the edge cases in every single instance, and how do I think about it, right? Yeah, I mean, I think that's really the problem, is just thinking about all the edge cases and kind of see if you can do it in a good way. Yeah, and I feel like it's going to be a linear time type thing. So yeah. Only because you have to look at each node to see if they're inbound. Roughly speaking, probably. But yeah. And the way that I would also think about it is that instead of keeping, let me make sure I'm reading this right, keeping things in low and high is trimming things that are smaller than low and then trimming things that are higher than high. And of course, in here, there's some sort of invariant that we would have to make sure that we maintain. And here we want to return the root of the trim tree, and of course the root can change. Okay, so let's say, yeah. So then now let's say we have a recursive function. Let's call it trim, and we have a node, right? So let's say we have trim of root, which will return the new root. Okay, then so now the problem, as I said, becomes thinking about every possible instance. So let's walk through it together, but obviously the first one is going to be if the node is none, then that's fine. If no.value is less than low, what does that mean, right? That means that this node and everything to the left of it should be removed. That means that this node should be replaced by everything to the right, recursively, right? So then now we can maybe do something like, I don't know if this is quite right, but something like this. And similarly, if that value is greater than high, of course these things are mutually exclusive, as you can probably figure out. If this is bigger than the highest node, then we want to keep it by the left. Otherwise, what happens, right? That means that this is inside the node, and then now we try to figure out, what is happening. So that means that if this node is inside the node, then left node is equal to trim of node.left, because it's just recursiveness, and the right node is also just trim of that, and this should be good, and then we return node otherwise. This feels a little bit easier than I remember. I feel like I would also say that very often I do struggle with these problems because, and I say this the same thing with respect to the linked list. but also binary search tree, is that these problems don't really come up in competitive. So even though I am well practiced and I know the theory, there are a lot of silly, just like I'm not practiced that much, right? Because it doesn't come up in my competitive career, and of course in real life not so much either. But yeah, the idea here is that the left node, we take whatever the left is, the trim version. I'm trying to think through all the cases a little bit. Here is that we want the right side, but of course this is recursive, and I think that's the problem that's true, is that everything to the, so that node we want to remove and everything to the left of it. Here we want to get the return of the trim of the version. I'm gonna give it a submit, and apparently, yeah, I'm not wrong in my remembering or my memory. Oh, look, the streak thing is back. Is this did I record it? Huh. Okay, that's good. 7:45, yay. But yeah, I got a lot of wrong answers before, because I remember I think of this more like this is a problem that I definitely struggle with. And we look at the code, there's a lot of you know, things out here. Thinking about the parents and stuff like that. But this is clearly a little bit clearer today. And it's just, it's tough. Basically a trim of node. I think to step back a little bit, trim of node returns the node that is without any out of bounds element. And that might return recursively, right? I think that's the part that's a little bit tricky, is that you could move it up. And for me anyway, the part that makes this a little bit tough is the recursive part. Like you move it up and then you look at that element constrained by those bounds, and then you can also move those up depending on how it goes, right? And it can really go a number of ways. I think the thing is that which I don't think I did a good job of illustrating, is that these two things are mutually exclusive. That means that if node rise is smaller than low, then this recursion means that none of the nodes will be. No, that's not true, I guess. I don't know. It's tough. But yeah, but the worst case is gonna be linear because of this thing, and you basically do a pre-order traversal of the node or something like that, and yeah, or maybe post-order depending on how you want to say it on this check. But yeah, so it's gonna be linear time and O of H space, where H is the height of the tree because you have to go through it. Because I don't think this is balanced, right? If it's balanced, then you could say something more strictly with respect to O of log n, right? But it's the bound. But otherwise, it's still O of H is the height. That's all I have for today. Like I said, not 100% right now, so I'm maybe a little bit not as detailed. Hope you understand. Hope you're okay with that. That was 745 day streak going. So yeah, hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great rest of the weekend. This is Friday already, so yay, party time. Stay good, stay healthy, take good mental health. I'll see you later and take care. Bye bye.